Hi, so we're going to be working on section 3.2, measures of variation. In section 3.1, we began by looking at two basketball teams. Actually, I'm going to share my screen so you can see a picture of these basketball teams here. Okay, and we notice that what we had remembered, what we had gone over in section 3.1, part 1, was we calculated their mean, their median, and their mode. And we had that the mean was 75 for both teams, and the median and the mode was 76 for both teams. And so whatever differences we saw in these teams, it was not becoming clear by just looking at the measures of center. So what we're going to do now is we want to just take a minute and look at the picture of these basketball teams and see if you can somehow describe the differences in team 1 and in team 2. So notice that in team 1, everybody's about the same height as compared to in team 2. We definitely have that one really tall guy here, 7 feet tall. And we have one guy that's a little bit shorter too. So there's something different about team 2 than team 1. That difference isn't measure of center, but in section 3.2, we're going to talk about measures of variation. And we hope that as we go through different measures of variation, we'll begin to be able to find numerical measures that describe the differences between the two teams. Okay, so I have up here the heights of the teams, and there are going to be 3 different measures of variation. The first one is range, and that's going to be max minus min. We're going to do that in a second. The second one is going to be standard deviation, and we'll do that next. It's really a central concept for the course. And then finally, we will go through another measure of center, but not, I don't think, in this video. Okay. So the next video will wrap that up. So we're going to start with the range. And the range is equal to the max. The max is the biggest number in your data set minus the min. All right. So for team 1, we have the maximum is 78 and the minimum is 72. So we see that our range is equal to 78 minus 72, or 6. So let me go store that over here on our table of numerical measures, 6. Okay, and let's get the range for team 2. Okay, and so my range is 84 minus 67, and I'm gonna have to do this off on the side here, 17. So if you guys can please take out your calculators, because we'll have quite a bit of calculation in this section, and it'd be really helpful if you went along with me, so that'll help you remember how to do it. Okay, so we notice now that we do find that the range for team 2 is much larger than the range for team 1. So this is a numerical measure which begins to explain the differences in the two teams. Great, okay. And so the next measure of variation that we're gonna look at is standard deviation. Standard deviation is without a doubt the most central and important concept in the course. And so I'm going to write it on the board. I think it would be great if you could open up your notebooks and write it on the front cover of the notebook. We will go back to this concept so many times that it'll be great just to be able to open up the notebook and see it right away. Front page, back, inside cover, wherever you can really access it. So standard deviation is how far on average the observations vary from the mean. So let me write that down. It being so important, I'm going to write the definition. We're going to we're going to have a very illustrative calculation of the standard deviation, and then I'm going to do a graphical representation as well. Okay, so starting with the definition of standard deviation, I'll write it up here. It's a measures variation by indicating how far on average observations that are deviate from the mean. How far on average observations deviate from the mean. Okay, so let me make a table of our observations for team 1, and then we will look at how far each of those observations is from the mean. Then we're going to do some special kind of averaging. So let's get okay, so I'm going to put my observations here, and then I'm going to subtract each of my observations from the mean, and I'm going to put it in the second column. So let's get the data into the first column. This is for team 1. Okay, and remember the mean for these numbers, you get it by adding them up and dividing by 5, because there's 5 observations, but we did that in section 1, and we got 75 as the mean. So we're looking here for each value, x refers to each of the observations, x minus 75. So this is 72 minus 75 is minus 3. 73 minus 75 is minus 2. 76 minus 75 is 1. We got another one of those, and 78 minus 75 is 3. So I want a measure of how far on average these observations vary from the mean. So if I went ahead and just averaged them up, when I sum all these up, what do I get? The sum is equal to 0. These are called deviants because they are how much the observation deviates from the mean. When we sum up the deviants, it's always 0, the deviance from the mean, okay? And so we can't just go ahead and jump in and take a straight average because it doesn't give us a feel of how far on average observations are from the mean. So we have to do something to make these values positive, and we have a couple of choices. One of them is to take absolute values of them, and the other is to square them. And we're going to use we're going to square them because that's what's standard in the discipline, but also because when we square them, we end up with optimal statistical properties again. A concept that's going to be more interesting in like a more mathematical statistics course than in this course. So let's go ahead, and what we want to do here is square each of these. So minus 3 times minus 3 is 9. Everything in this right column should be positive. Then we get 9 and 4, 1, 1, and 9, 24. Okay, so then now we have to take some kind of average. So I'm actually going to stop in the calculation and put your formula on the board, the sample standard deviation. Okay, and then we will kind of figure out what we're supposed to do to get to finish up this calculation of standard deviation. All right. So the sample standard deviation, we'll start with its square. S is going to be standard deviation. The notation for the sample standard deviation is S, okay? S squared is equal to the sum, x minus x bar squared, divided by, I know we want to divide it by n because it's an average, but we're going to divide it by n minus 1. And the reason around that is actually, again, something more interesting in a mathematical statistics course. But if you guys want to talk about that, bring it up in class, and I can give you a little more intuition around why we reduce this by 1 in the denominator. Okay. It's a little different, by the way, when we calculate the standard deviation for the population. So it's not the same formula, and that kind of is important to keep what's going on in the sample separate from what goes on in the population, as we discussed in the last video. Okay, so this is that formula for the square of the standard deviation, and then the standard deviation is the square root of s squared. Okay, so we're going to looking for my calculator here on the off on the side. All right, so we have this number here, 24, which we got from squaring and then summing all the deviants. So this is actually my numerator. Right, that's my numerator. So we have then s squared is equal to 24 divided by, I'm just going to put this in a box, and then I'll put this in a box so that you know what part of the formula I'm working with. Okay, and so it's 24 divided by 5 minus 1, or 24 over 4, and that's equal to 6. So the standard deviation is going to be the square root of 6. Standard deviation is the square root of s squared. I'm just getting to the calculator here. And we get 2.45. Just check that. Yeah. Okay. So my standard deviation is 2.45 for team 1. And to interpret that, and in the notes, I think I have that as 2.4. So, you know, maybe we can even keep it there so that the video kind of lines up better with the notes. So if we go back to the definition of standard deviation is how far on average observations are from the mean, okay? And this standard deviation is 2.4. So if we look at these deviants here and think about just their absolute values, it's important to confirm that 2.4 could possibly be some measure of center of the absolute values of the deviants. And in fact, the deviants go from 3 to 1, and 2.4 is in the center of that. So that's a good check. Had I forgotten to take my square root, then going back and checking those deviants and to see whether or not the number that I think is my standard deviation is in fact in the center of the fray there, you would catch that error. So I don't have any students making that error anymore. So that's really good. Okay, so this is the standard deviation for team 1. And then what we want to do is let's calculate standard deviation for team 2. And then we'll do a graphical representation of both of those variabilities from the mean, both of the standard deviations. Okay, so I'm going to look at team 2. Let's say we can put it up here. You guys, if we were in the classroom together right now, I would be asking you to calculate this on your own. So maybe I should try to be a little quiet while I calculate it, and then you guys can calculate it, and you can look back up at the video and check as you go. But that's kind of a helpful thing right now for you to calculate the standard deviation for team 2. You can refer back to the standard deviation for team 1 calculation and just try to go through the same process. Remember that the mean for team 2 was also 75. So we're looking at deviance from the mean. Okay, I think I got them right. I hope I got them right. It's a nice step to check for accuracy is to check that the deviance sum to 0, and then go ahead and sum up your squared deviance. I'm getting 156. Okay, remembering that that number is my numerator and my standard deviation calculation. We'll go s squared is 156 divided by n minus 1, which is 5 minus 1. Okay. What do we get? It's 39. S squared is 39. And the square root of that is 6.2. So what we have is that the standard deviation for team 2 is 6.2. Let's go, we can check two things. One thing we can check is that 6.2 is somewhere in the middle of the absolute values of our deviance, and it is, so that's good. And then also note that the 6.2, the deviation for team 2, seems to be bigger. I mean, the standard deviation for team 2 is bigger than team 1. So let's go ahead and get that into our table here. Okay. All right. So now what I'm going to do is I want to build a graphical representation of what the standard deviation is. And so I'm just going to erase, so I'm going to put it over here. We can leave. Just leave them there. Okay, so the first thing I'm going to do is I want to build a dot plot. And I'm going to do a side-by-side or an up and down dot plot for team 1 and team 2. So we need a horizontal axis. And that axis, I'm going to put all the data on the same axis. So I'm going to start with 67 and go to 84, and that will be an axis that's big enough for all of our observations. Okay. All right, so there's my axis here. I'm going to come in, and for team 1, I'm going to dot plot above the axis. So I have one observation at 72. I have an observation at 73. I have 2 observations at 76, so I'm going to just stack them up there. And finally, I have an observation at 78. So that's about here. Okay. Now what I want to do is graphically display how far each observation is from the mean. So I'm going to draw a big horizontal bar at the mean, 75. Okay, so here's my mean. And I'm going to pick up a green marker. In this class, so occasionally we will be dealing with things that are either deviants or similar to deviants. And I'll try to remember to have a green marker so that the green becomes something that we use in the class to identify deviations. Okay, so, and let's just look at this one. This first guy right here, right? So there's that point at 72. And here is a bar that's 3 units long, just like its deviant is 3 units away from the mean, right? And this point here was 73, and there's that deviant. And we have two green bars here from 76. They each have length 1. Okay, and then finally we have this deviant, we have this data point at 78, and we want to make a green bar, a horizontal green bar that the length of the bar represents how far the observation is from the mean. So we see here, these are 3, length 3, length 2, length 1, length 1, and length 3. The green bars represent your deviation, and your standard deviation is some average of these bars. Okay, so now what I want to do is I want to do the dot plot for team 2, and then we're going to look at the green bars for team 2. Okay, the deviance from team 2 graphically. 67 is my first observation. I'll just dot plot underneath. 72. 2 values at 76, and we're going to stack them up, and 1 value at 84. Okay, so we're going to look at how far each of those observations are from the mean, okay, and the total amount of green gives you an idea of how much variability there is in the data. So each of these dot plots have associated with it a green bar. And if you look at the amount of green here, well, let's just make sure we identify each piece. So 67 is 8 units away from 75, the mean, okay? And 72 is 3 units. 76 is 1, and I have that represented twice. And then finally 84 is 9 units away from 75. So what we see here is that for team 2, there's a whole lot more green, right, than there is for team 1. Okay, so this is the sample standard deviation, the formula, the definition, the most important definition in the class. We have calculations and a graphical display. All right. We'll call it that, and I'll see you in the next video. We're going to move forward and discuss some more things about standard deviation and measures of variability.